All right, what is up? Happy Saturday, folks. In order to become better at understanding and using these large language models and AI systems in general, we have to understand the basics. I know nobody really likes these videos, but they help me and they will help you. I promise if you watch these, you will get a pretty good understanding, basic levels, and you will be a better AI enthusiast.
Hooray!
Today we'll be talking about parameters and activation functions. Unfortunately, this was all clickbait. Really, we have to start by talking about the structure of a neural network. So before we can actually talk about weights, biases, activation functions, parameters, and all that jazz, we're going to want to identify the different ways that computers can, quote, think and act with minimal human input. And then we want to take a look at the differences between machine learning and deep learning. And finally, we'll take a look at the components that make up a multi-layer perceptron, which is one of the simpler architectures used in deep learning. And fortunately, the components used in the multi-layer perceptron are roughly the same components used in transformers, and this should give us the basic understanding that should suffice in our journey to learn about parameters, activation functions, sequences, tokens, transformers, and finally the overall method that large language models are using to function in the ways that we want them to. So let's get to it. Today we are really just going to be doing one more base layer before we get to the meaty stuff, so bear with me. Alright, so let's take it back a step and just look at the basic difference between the different ways to do things with computers. Starting at the top, we're going to go with an algorithm. Now, algorithms are not computer specific. Baking a cake, changing the oil of a specific car, algorithm. Algorithms are a well-defined set of instructions that's very reproducible. By following the steps or the instruction with the correct input, assuming you have all the materials that the instructions call for, you should get the desired result. So baking a cake, it doesn't matter where you are. If you have, eggs and flour and a little bit of love or something like that, I think that's the recipe. If you have those inputs, no matter where you are, if you follow the exact steps, you will get out a cake. Changing the oil of a specific car, there's steps that you need to take, and it doesn't matter where you are. If you follow those steps, you have the right tools, the correct bolt sizes, the correct oil, the right filter. No matter where you are, you follow those steps to the T, you will change the oil successfully. You give those instructions to someone else, you give the tools, the inputs to someone else, they will be able to successfully change the oil of that specific car, no matter where they are. Okay, next there's artificial intelligence, and I would say that this is an algorithm to mimic human behavior. So way in the past, maybe the 60s, the 70s, a lot of artificial intelligence would be extremely algorithmic. You'd have a machine that would complete a task with specific inputs and specific outputs. If any of the inputs are changed or in a different position, the robot would continue as if they were in the supposed defined position and fail if they weren't. No learning, but still mimicking human behavior. And to an outside observer with no knowledge of the system, it would look like the machine had some sort of ability to do things beyond what was normally defined to be the capabilities of a machine. And then we move another layer deeper to machine learning. Machine learning is any algorithm that can learn from data. This includes spam detection, video recommendation, friend suggestions, anything where you have a program making inferences about unseen data. That is the learning aspect. Getting the machine or system to develop an understanding of how to perform the task without you explicitly telling it how to perform the task. And finally, deep learning. This is using artificial neural networks to mimic the learning process of the human brain. So with machine learning, we are trying to find a trend in some structured data. So we go back to the spam detection. The data is structured in that you have emails with words that are possibly predefined. You have an email with a set of words, and if there are this many words in the email, it's probably spam. Or we have an email user, and we have a set of likes and preferences, a list of their contacts, and if it either has too many words in this set or it doesn't have enough relationships to emails in their contact list, it's probably spam. Video recommendation, the same thing. thing. There's a list of videos that the user's seen. There is a list of videos the user has seen but disliked, a list of videos the user has seen and liked. This is all information you can put in a spreadsheet and compare the values with one another. And then when given a new piece of data, you can see how it fits in the set of data that has a comparison made for it and predict its proper location on the spreadsheet. Deep learning, we're trying to find a way to use data that can be structured or unstructured. This data might not necessarily fit on a spreadsheet very well. Like an image. If we have an image and we want to classify the image in a certain way, it's hard to put the image on a spreadsheet other than giving it a value. But the actual pixels that make the image are hard to quantify in a manner that is easily put in a structured form. So we want to use deep learning and neural networks to find a way to make some trend in this unstructured or structured data to predict, create, or classify unseen data in a way that is useful to us. So now that we've gotten a good idea of what the different algorithms are, we talked about the different types of models we'll be looking at, take another step back and clarify what exactly we're doing. So the main goal is to get a set of inputs and predict the correct output. Maybe it's a classification, maybe it's a new image, maybe it's the next word. But at the end of the day, we're taking inputs and we're trying to predict an output. Say we have the height, the weight, and the color of an animal, and we want to figure out the breed of the animal. Perhaps it's a dog. The breed of the dog given a height, weight, and color. This is pretty basic. There's only 3 different inputs. We can think of them as an axis, and we can use a traditional machine learning algorithm such as KNN to get a pretty good prediction based on those 3 inputs. But as inputs become more complicated, a deep neural network has been shown to be the most effective way to make these predictions. But the idea of predicting appropriate outputs given a set of inputs is exactly the same. We're going to want to use weights, biases, and activation functions to change the inputs to produce the desired output. And we're going to go ahead and end it there.
Hooray!
Next video, we will be taking a look at the multi-layer perceptron, which is really just a sequence of fully connected layers taking an input to an output. And again, that's all we're doing here with all of these models. We're taking an input and we're trying to get the output that we desire. The inputs are usually formulated to eventually become a set of features that represent the original input in a lower dimension so that it's easier to organize and process. For images, there's a certain way to do this using convolutional layers, trying to find filters. For the large language models, we're going to do some form of tokenization to get some mapping of embeddings and positional encodings between different groups of letters and spaces and characters. But the general idea here is we are creating an algorithm to develop an understanding of the data without excessive human input to make predictions or inferences about the input on its own. Inputs to outputs. Changing the values of these numerical inputs with simple matrix multiplications, additions, and passing these values through functions to create a curve to allow us to estimate final values. And that's pretty much all there is to it. Thanks for watching this video. I know nobody likes these videos, and I know that there's a ton of things that need to be installed. I just want to get a good baseline understanding, and all the new models that I've seen, except for the Segmenter by Facebook, which looks really good. That came out maybe 2 or 3 days ago. They're all just implementations of either the Alpaca training system or GPT-J style things that have already existed for about a couple of years now. So if you really want to see this, keep bugging me and I'll put something out, but it's nothing seriously new, and there's no new set of data that's anything to really play with. Llama was cool because there was supposedly there was a set of weights that it was a full production model supposed to be on the same scale as GPT, where the weights actually were leaked. That was cool. It was something big time that was trained on a professional set, you know, hundreds of thousands of dollars of machinery. It was a big thing. These other models, they're cool, but they're smaller. It's not big time production stuff. Nothing is heavy, but we'll still take a look at this. To segment anything though, this is sick, and we'll take a look at this. Truthfully, I've been busy with other things, mainly school, So I got about 4 or 5 more weeks left of school, and then we'll be on this all day, every day. A lot more content specifically about trying out new things. I've been in school this whole time. So ever since I started this channel, I've been in school. So you haven't really seen the channel with no school on my back. So stay tuned. It will definitely get better. I'm trying to get better at video editing as well. Hopefully you can see that. Still pretty rudimentary video editing skills, but starting to add more images. I tried to normalize the audio. It wasn't really working that well. Lots of things coming. I really appreciate the feedback and back and forth that I've been getting. I know I've been kind of distant the past couple weeks, but things will only improve from here on out, I promise. Like and subscribe as always. I hope you have a fantastic Saturday or whatever day it is in the future. Peace.